Hello guys, in this series of videos we are going to talk about calculus in physics. Now, why do we need calculus in physics? In physics we need to calculate quantities like displacement and velocity and acceleration. Now what is velocity? Velocity is rate of change of displacement, and what is acceleration? Acceleration is rate of change of velocity. Now what is this rate of change of? It is time rate of change of, we say it, right? uh, Velocity is rate of change of displacement, and acceleration is rate of change of velocity. So in the first one we need to understand how the displacement changes with time. The second one, how velocity changes with time. Correct. Now here, while discussing uh, um, velocity or displacement, we talk about instantaneous values. Now what is instantaneous values? Instantaneous value of velocity is the velocity at that particular instant. At that particular instant. Now here when we say velocity or speed, it is the change in displacement upon time. Or when I say change in time, I start from time t is equal to 0 and t is equal to some value. So change in time. Now why I'm saying change in time, it is because my time at t is equal to 0, it may be somewhere. Okay, at t is equal to t1 it reaches somewhere, at t is equal to t2 it reaches somewhere else. So now I want to find the change that has taken place from t is equal to t1 to t2. So I'll be doing t2 minus t1. Now if I'm starting from t is equal to 0, then over there my t1 will take value equal to 0. Correct. So this is change in displacement upon change in time. Now when I say instantaneous, that means the velocity at that particular instant. Now what is an instant? If I tell you, give me that book right now, okay, can you do it? You cannot, because the moment I said right now, that moment has gone, so it can never happen. Okay, so when we say instantaneous, instantaneous means very small interval of time. That means this value in the denominator, it is very small. So of course if the time interval is very small, then my change in displacement is also going to be very small. But then for finding displacements, right, for finding displacements, I need to take the value of time very small, or it would be approaching 0. It may not be 0. Now for this I'll give an example why this something approaching 0, we call it something tending to 0. Okay. Now there was one teacher who was teaching division to elementary school kids. Now he had some fruits and he gave them those fruits, a group of 10 students, and he had 10 fruits. Correct. He started from the first one. For the first kid, he gave 2 fruits, and second student he gave 1, third he gave 3, and so on. But then what they found is the fruits got exhausted, and then finally he gave 1 fruit each to each one of them. Correct. Now that means what they could infer, if the number of fruits and number of students, if it is same, then each one of them will get 1 fruit. Correct. So if I have 10 fruits and 10 students, if I give each one of them 1 1 1 1, so if I distribute them equally, then each student gets 1. Okay, so when the number of fruits and number of students is same, everyone should get 1 fruit. If it is 20 students and 20 fruits, everyone gets 1 fruit. So now one student from there, he asked the teacher that if number of students and number of fruits is same, then each one should get 1 fruit. What if the number of fruits is 0 and number of students is 0, does each one get one fruit? So then obviously this is something not possible, correct? This quantity 0 upon 0 is something which cannot be determined. And you know who this student was? He was Srinivas Ramanujan. You may have heard of Ramanujan's number is a very famous number. That number is 1729. And what is so special about this number? It is the smallest number which can be expressed as sum of cubes of two different pairs of numbers. So this is equal to 1 cube plus 12 cube and 9 cube plus 10 cube. It is the smallest number which can be expressed like this, correct? So that is where this concept of 0 upon 0. Now why I said 0 upon 0, how it is relevant here in our calculus. Now here when I'm talking about instantaneous velocity, my change in displacement and change in time, if my change in time approaches 0, my change in displacement will also approach to 0, but then it will not be 0. Okay, let us understand that. So that is where I need this, and for handling operations like this in physics and mathematics, this is what comes for our rescue. Now when we start calculus, we need to understand the concept of limit, or they say in derivatives you have something like dy by dx. Now what is this dx? The dx is a very small increment in x. Now again, what is x and what is y? Y is a function of x. X is my independent variable and y is dependent variable. As x changes, my y changes. Okay, and now I want to find how my function y is changing as my function my variable x changes, correct? So that is what is derivative of a function. Now let us do that step by step. I'll give you another example. I have one rabbit sitting over here, R1, and second rabbit sitting here, R2. Let us assume that distance between them is 4 meters. Now rabbit 1, R1, he can jump. Rabbit 2 is sitting there, he is stationary. Okay. Now this rabbit 1, he keeps on jumping, he wants to reach rabbit 2 there. And how does he jump? Now every second he jumps half the distance between them, correct? Now he starts jumping. Okay, at t is equal to 0, my rabbit R1 is at A and he wants to reach B. So at the end of first second, my rabbit R1 from A, he jumps 2 meters. In second, he jumps. Now what is the distance remaining between them? It is 2 meters now. Now in the second, he will jump 1 meter. In the third, now again, what is the distance remaining? Now it is 1 meter. In the third, he will jump half, and so on. So every second, it jumps half the remaining distance towards the second rabbit. Okay, R2. Now, when will my rabbit R1 reach rabbit R2? The answer is never. Because every time, the distance remaining is, half. So whatever distance remains, half of that he jumps. Okay. Now the distance remaining may be 10 centimeter. But if it is 10 centimeter, he will jump 5 centimeter. Now remaining is 5 centimeter. It will be 2.5. Now again the remaining is 1.25. It will jump half of that. So my rabbit R1 will never reach rabbit R2. At some point of time, the distance between them will be very small. Okay, but still he will be jumping half of that very small distance. Correct. Now half of that very small is still remaining, so again half of very small will be there. Correct. Rabbit R1 will never reach rabbit R2. Now at some point of time, the distance delta x, between the rabbits is going to be so small, it's going to be approaching 0. So this is called delta x tends to 0. I'll write delta x tends to 0. Correct. Rabbit, that means rabbit R1 tends to, when the distance tends to 0, my rabbit R1 will tend to rabbit R2. That means rabbit R1's limit is rabbit R2. So as my delta x tends to 0, rabbit R1 tends to rabbit R2, that means rabbit R1's limit is rabbit R2. Now when I say delta x tends to 0, that means this delta x is very small. Now how small? Now when I say very small, that is that is a vague term, right? Because if I ask you how much water is there in Powai Lake? Now here the answer is, I want exact answer. Does anyone of you know exact answer, or does anyone of you know correct answer? So if you ask me, I will say bahut hai pani, right? But then what is bahut? What is so much of water? Correct. Then those terms are relative. Correct. This delta x tends to 0, that means it is approaching 0. It is that number, value of that number is something which you cannot even imagine. Correct. Such small quantities are called infinitesimally small. What is infinitesimal? When I say infinite, I am talking about large quantities, and when I say infinitesimal, it is very small. Infinitesimal, that means very small. Now let us have some some mental exercise here. Okay. Now coming back to that tail of that rabbit. Now if my x tends to y, correct, then what would x minus y be? If x tends to y, this arrow mark, this sign, arrow sign, it is not equal to sign. X tends to y, does it mean that x is equal to y? No, x is approaching y. Then x minus y would be how much? The answer to this would be, it would be infinitesimally small. Infinitesimal. Correct? I would also say x minus y is not equal to 0. It would be some quantity which is very small. Now what about infinitesimally small quantity? Okay, and there is another quantity, 10 raised to power, let us say minus 10 . I can go on. Now which one of these two is small? Obviously this would be small, because when I said infinitesimally small is something that you cannot even imagine. Now is this something I can imagine? Yes, I'm able to write it here. This is the exact value of what of this quantity. Correct. I know the number of zeros. Correct. I know this value, so this value is definitely larger than this value because this is something that I cannot imagine. Correct. Now suppose I have this infinitesimal. Okay, now my next question would be infinitesimal multiplied by 10 raised to power maybe I can have that many zeros here, which I don't want to write right now. Only thing is that here your power is negative, here it is positive. Now what about this? What would be value of this? This is a large number, but then this number on the other side, okay, it is infinitesimally small. It is something that you cannot imagine how small. Correct. So that means this product is going to be again infinitesimal. And finally, for this video, I'm going to have one more question. What is 1 upon infinity? What is infinity? You must have heard that there was a movie called The Man Who Knew Infinity, and that movie was on this Srinivas Ramanujan. Okay, now what is 1 upon infinity? You divide something by 0, we say it is infinity. So this is 1 upon something by 0, let us say x upon 0. So that would be equal to 0 upon x, and that would be 0. So reciprocal of infinity is 0. Right? So that is about calculus and use of calculus and the concept of limit, and then that dx. This, when I say delta x tends to 0, that infinitesimally small increment in the variable x, that is called dx. So something which is very small is called dx. Okay, in the next video we are going to talk more about derivatives of functions and derivatives of some algebraic and trigonometric functions. Thank you so much.